Okay, let's start. Let's start. Let's start. මම ඔයාලට මේ උදේම අර පියෝ පේපර් එකේ ඩිස්කෂන් එකක් කරන්න පටන් අරගෙන ඊට පස්සේ ඊළඟ තියරි පාර්ට් එකට එන්න. මම ඔයාලට දැන් පේපර් එකක් දෙන්නම්. අර මේ පේපර් බුක් එකක් නෙවෙයි වෙන එකක්. වෙනම එකක් පේපර් එකක් දෙන්නම්. අපි ඒක ක්වෙස්චන්ස් කරන ගමන් පොඩි ඩිස්කෂන් එකකට එමු. හරි. හරි මම ඔයාලට මේ පේපර් නම්බර් 3 එක දුන්නා. විනාඩි කිහිපයක් නිකන් පේපර් එක පොඩ්ඩක් රීඩ් කරන්නකෝ. පේපර් එක නිකන් ෆුල් රීඩ් කරන්න විනාඩි කිහිපයක් ගන්න. විනාඩියක් බලන්න දැන්. ඔයාලට මම papers දෙකක් දැනට දුන්නා. paper number 3 4. paper number 3 pure paper. paper number 4 applied paper. හරිද? ඔයාලගේ මේක හොඳ papers දෙකක් තියෙන්නේ pure එකේ applied එකේ. අපි ඉස්සෙල්ලා pure paper එකේ discussion එක කරමු. applied එක අද සමහරට කරන්න බැරි වෙන්න ඉඩ තියෙනවා. ඒ වුණාට ඔයාලට කරන්න දුන්නේ ඒක මේ pure paper එක පොඩ්ඩක් විනාඩි දෙක තුනක් සම්පූර්ණයෙන්ම තනියම කියව ගන්න. ළඟ ළඟ කට්ටියත් එක්ක සෙට් වෙලා නෙවෙයි තනියම කියවන්න. බලන්න හැම පේපර් එකකම ප්‍රශ්න 17ට යනකම් ඔක්කොම තියනවාද කියලා. ප්‍රශ්න 17ට යනකම් ඔක්කොම තියනවාද කියන එක බලන්න. Okay, read it now. Read it. Okay, now let's start the paper from the beginning. Start question number 1. Start question number 1. Do as soon as possible. Do as soon as possible. Okay, if you have any doubt, do with me. Here question number 1 given irrational expression. We need to rationalize it. We need to rationalize it. To rationalize that, need to multiply by the conjugate of denominator. Na? Then here 3 minus root 5, 7 minus 3 root 5, 3 root 5 plus 2 root 5 minus 1. So we have two terms. Here we have two terms. Then for this case, don't get common denominator first. Don't get common denominator first. You better to multiply conjugate of denominator each and every term. Okay, each and every term. Now, here take this one. 7 minus 3 root 5, 3 minus root 5, here conjugate 7 plus 3 root 5, 7 plus 3 root 5. And similar thing here, 3 root 5 plus 2, root 5 minus 1, here root 5 plus 1, root 5 plus 1. Now expand 21, 9 root 5, here minus 7 root 5 and here 3, 5, 15, minus 15. Here 7 square minus 3 root 5 square, difference of 2 squares. Continue here. Then here 3, 5, 15, 3 root 5, 2 root 5 plus 2. Here root 5 square minus 1. So if you have in doubt, do with me. Others do alone. Then 49, 9, 45. Here 21, 15, 6, 9, 7, 2. Here 5 minus 1. Here 15 to 17. 3 to 5, root 5. Now here 49, 45, 4. Here common denominator 4 now. Then 6, 17, 23 plus 2 root 5, 5 root 5, 7 root 5. Here the simplest form. Simplify by rationalizing the denominator. Okay. Definitely for your term test there will be rationalizing part. So you need to multiply by the conjugate of denominator. That's it. You need to multiply the conjugate of denominator. That is question number 1. Okay. Continue. Do alone. Okay. Then question number 2. Question number 2. Here need to find domain and range. Need to find domain and range. So range means possible y values with respect to x. Possible y values with respect to x. No? Here this is very special function. It is rational type function. To find range of this function, you need to subject x. When finding range, just subject x. Then here function y equal x square plus x plus 3 over x square plus x plus 1 cross multiply x square y xy y x square plus x plus 3 and take this on the other side, then y minus 1 x square. Here y minus 1 x plus y minus 3. Now you find possible values of y, possible values of x. Then x equal minus b plus or minus b square minus 4ac root divide by 2a. Likewise you find it. Now better to simplify this one. So here you need to think. Here we have rational expression, then denominator zeros must be eliminated. Again we have square root term, that means irrational term, then within square root must be positive or 0, no? Then both must be considered. Therefore let's do this. Y minus 1 plus or minus, here take y minus 1 outside, then y minus 1 minus 4y. Minus 4y plus 12. Whole thin root 2 into y minus 1. Then minus y minus 1 plus or minus y minus 1. Here minus 3y plus 11. Minus 3y plus 11. Root over 2 into y minus 1. Now you need to check further the possibilities. Now for rational expressions, y minus 1 not equal to 0, then y not equal to 1. Here one thing. The another thing, here within the square root must be positive. Here n y minus 1 into minus 3y plus 11 must be greater than or equal 0. Then y minus 1 take minus outside, 3y minus 11 greater than or equal 0, need to solve this inequality. Y minus 1, 3y minus 11 less than or equal 0. Now here the inequality 1, 11 over 3 with equal, no? For that case with equal. Here positive, positive. Okay, now you need to compare both. Then final answer you need to consider. Then here y not equal 1, here y 1 to 11 over 3. Therefore range of the function y such that y in between 1 to 11 over 3, only equal with 11 over 3, not equal with 1. Okay. So anyhow, when you find the range of rational function, you take y and cross multiply, get quadratic equation, then solve it, then check the possibility of y. Check the possibility of y. Here denominator zeros must be eliminated. Within square root, value must be positive or 0. Both must be considered there. Both must be considered. That is question number 2. Continue. Always remember, domain mean possible x values. Then if you have a rational type, you eliminate denominator zeros. Then if you have square root terms, within the square root must be non-negative. 0 possible, positive possible. Then if you have logarithmic expressions, logarithms, then definitely you need to get within logarithms positive. That's the thing. So when you find in range, you subject x. So when you find in domain, you need to subject y. So already y has subjected. Okay. So when you find in range, subject x. So here quadratic relation, then you subject, then here quadratic equation, then get formula and check the possibility of y. Then here we have denominator 0. You will remove it, y not equal 1, and we have irrational expression. Then again, within square root must be positive. Now, within square root must be positive. That is question number 2. Continue. Just ask me, do alone. තනියම try කරන්න. නැත්නම් අර පත්තු වෙන්නේ නැහැ ඔයාලා. ගණක් හදද්දි මුලින්ම. ඒකින්ද ළඟ කට්ටිය පත්තු කරන් try කරන්න එපා. ඒක එහෙන පාඩුවක්. Okay, then question number 3. Question number 3. Here this case, function given ax cube plus bx plus c, that means cubic function, no? And further given a factor x square plus px plus 1, factor given. So factor, quadratic factor. බලන්න මෙතන මේ domain එක ගන්නක් තියෙනවා. Domain possible x values, then domain always real set, no issue for the domain. So here we have rational type, but denominator 0 is not there. Denominator 0 is not there. X square plus x plus 1 කවදාවත් 0 වෙන්නේ නැහැ. Then denominator 0 is not there. Therefore domain real set, range is this. Okay. Then question number 3. Question number 3. So here given cubic function. Here given cubic function ax cube plus bx square plus bx plus c. So here given factor x square plus px plus 1, given factor is this. Then there will be another factor, no? Here cubic relation, here quadratic relation, there will be a linear type, linear factor. Okay, there will be a linear factor. So here we have quadratic one, no? Then we can't use factor theorem directly. Then definitely if you can't factor theorem or remainder theorem directly, you better to go to algorithm. Okay, then here it is now. Then linear factor, the leading term here coefficient a and constant term here c, no? Then you better write here x square plus px plus 1. When you compare x cube coefficient, you better to put ax. When you compare constant term, you better to put c here. Then definitely the factor like ax plus c. Factor like ax plus c. Now we have checked these two, no? Then you expand this one. Ax cube x square c p ax square p cx ax plus c. Then ax cube c plus pa x square pc plus a x plus c. Now these two terms okay, no? These two terms okay. Then you check the other coefficients. Then x square coefficient, here 0, here c plus pa. Then x coefficient, here b equal pc plus a. Pc plus a. You need to remove p here, then take p minus c over a. Minus c over a, put it here, b minus c over a plus a, then multiply ab equal minus c plus a square. Then here again another c have, na? C times c over a. Then a square minus c square equal ab. A square minus c square equal ab. Okay, complete now. Complete. So here cubic function, quadratic factor given, then this will be linear factor. You take that by comparing leading term and constant term coefficients, thereafter equate coefficients. Okay, complete. That is question number 3. Do alone. Question number 4, there are small correction for second part. Make it a but you better write minus son over x minus 2 square into x minus u. Better write this one. Hence deduce part. Better write minus sun of x minus 2 square times x minus 3. Okay. Then question number 11. Sorry, question number 4. Question number 4. Here need to write 1 over x minus 2, x minus 3 as a partial fraction. So here you can write x minus 2 minus x minus 3 over x minus 2 x minus 3. Then we can cancel x. The remaining upstairs will be 1. Then separate denominator. Then x minus 2 over x minus 2 x minus 3 x minus 3 over x minus 3 x minus 2. Then simplify. Cancel common factors. Then 1 over x minus 3 1 over x minus 2. We have usual technique, but I have done that different method. Okay. So we have usual technique. So you can write a over x minus 2, b over x minus 3 and so on. No? Here we can easily see factors x minus 2, x minus 3, linear factors. No? Then don't worry about that. We can just write x minus 2 minus x minus 3. Then we can cancel x. And here 3 minus 2, we can get 1. Okay. Therefore finally 1 over x minus 2, x minus 3 partial fractions 1 over x minus 3, 1 over x minus 2. Here it is. Then by that one you need to deduce the other one. No? Then we need denominator x minus 2 square. I told you to change this one. No? You need to correct this one. Here 2. Then 1 multiply minus 1 over x minus 2. Then 1 over x minus 2 x minus 3 times 1 over minus 1 of x minus 2. Then here this part minus 1 over x minus 3 times 1 over 1 minus 1 of x minus 2 minus 1 over x minus 2 minus 1 over x minus 2. Then here 1 over minus 1 over x minus 2 square x minus 3. Then here minus 1 over x minus 3 x minus 2 plus 1 over x minus 2 square. Then for this part you rewrite partial fractions, take minus outside. Then 1 over x minus 3, 1 over x minus 2, 1 over x minus 2 square. Now finally partial fractions 1 over x minus 2 plus 1 over x minus 2 squared minus 1 over x minus 3. Here are the partial fractions. So you need to practice that deducing part well. Here first part very simple thing. You can do usual way. Thereafter by that one you need to deduce the relation. That is question number 4. Continue. Take time. Now question number 5, modulus inequality question. Question number 5, y equal 2 times x plus 2 modulus y equal x minus 3 modulus. Take y1 and y2. Definitely for your A-level examination also there will be modulus inequality question. Okay, then exactly you need to practice this one. Then here y1, better write definition, 2x plus 2 for x greater than minus 2, minus 2x plus 2 for x less than minus 2, here 0 for x equal minus 2. Then y2, here x minus 3 for x greater than 3, minus x minus 3 for x less than 3, here for x equal 3, 0. Now you can sketch them. Here x-axis, y-axis. You don't worry about this coefficient. You can do usual way. Okay. So when here 0 value minus 2, that's why we check x greater than minus 2, x less than minus 2, and x equals minus 2. Okay. And here 0 value 3, that's why we check x greater than 3, x less than 3, and x equal 3. Now you can sketch. Here vertex minus 2, 0, mark it, minus 2, 0. Then minus 2, 0, here 2x gradient 2 intercept 4, 2 into 2, 4, here 4. V-shaped graph, here gradient minus 2 intercept minus 4, here minus 4. Then here y1 function, y1 function. Then x equal 3, here 2, 3 somewhere here. Then V-shaped graph x minus 3, here gradient 2, here gradient 1. No? Then slope somewhat less than previous graph. Here y1, here y2. Here y2. Okay. Likewise you can sketch. Then here check about gradients. Here gradient 1, here gradient 2. Then its slope greater than this one. No? Now we need to check 2 into modulus x plus 2 less than x minus 3 inequality. So when you consider this inequality, here this function y1 less than y2 case, then y2 is the greater value. Then when you compare here y2 line, so that is greater than y1, no? Then shade this region, that is the region. Therefore, now you find this value. To find this value, equate these two functions. So negative, here minus 2x plus minus 4, and here minus x minus 3. Now here minus 2x minus 4 minus x plus 3, take the other side, here x equal minus 7. Here this intercept will be minus 7 corresponding x coordinate. Then to find this value, you equate these two functions. Here positive one, 2 into x plus 2, 2 into x plus 2, then here negative minus x minus 3. Okay. By the gradients, you find which are the functions they cut. Okay. Now 2x plus 4 minus x plus 3, then 3x equal minus 1, then x equal minus 1/3. Then for this inequality, the region of the inequality here to here. Then x element of real set x such that x in between minus 7 to minus 1/3. Here the inequality solution. Solution for that inequality. Okay. Do up to that. Do up to that. Okay, now here there's special thing. There's special thing. Here the inequality 2 into x plus 2 modulus less than x minus 3. Here the inequality solution x in between minus 7 to minus 1/3. No? Now thereafter we need to convert this into 2 into modulus x less than x minus 5 modulus. Need to convert this. Now you check variables, then need to remove 2, need to put this one as minus 5. No? Then you replace x by x minus 2. Let's see what will happen. 2 into x plus 2 modulus less than x minus 3 modulus. No? Then replace x by x minus 3. X minus 2. X minus 2 plus 2. X minus 2 minus 3 like this. Now we get 2 modulus x less than x minus 5 modulus. So we can convert it up to that. Then similarly, you take the solution, replace x by x minus 2 again. Then x minus 2 minus 7 minus 1/3 like that. Okay. So here the inequality original one, its solution is this. Now you need to deduce this inequality solution. No? Then compare variables. Then to get this one x, need to replace x by x minus 2. Then same thing you do for the answer. Then here x minus 2, add both sides 2, minus 7 plus 2, x minus 1/3 plus 2. Then the corresponding answer will be minus 5x. Here 5 over 3. Here this will be the solution. Okay, that part very important. Na? From 2019 you will get this type of questions. 2019 ඉඳලා තමයි මේක set වෙන්න ගත්තේ. ඒකෙන්ද chance එකක් තියෙනවා හැම වෙලේම variable change එක දෙන්න. That is question number 5. Continue. Okay. Then question number 6, logarithms. Logarithms. Here in that case, special part again. So here we have two equal signs. So if you have two equal signs, you better to get another equal sign with t. Then you can go further. Then question number 6. Log t base a over b minus c log t base b over c minus a log t base c over a minus b. Then you put another equal sign. Here we have base t, no? Then you put another value k. Okay, like that. If you have two equal signs, you better to put another equal sign with t. Then for sign rule, for Lami's theorem and this type of questions, you better do that simplification technique. Now equate these two. Log t base a equal cross multiply k times b minus c. Log t base b, equate these two, k times c minus a. Log t base c, k times a minus b. Here third relation. Now we need to prove a to the power a to the power a, b to the power b, c to the power c. Then here we have a, no? Then to get a to the power a, you better to multiply by a here. And To get b to the power b, you better to multiply here b. Then 1 into a, 2 into b, 3 into c. Do this simplification. And again, we need to get product, no? We need to get product here. Then to get product, you add them. You add them. That's how we do. So, but now when you simplify this one, definitely you can get the answer. Then let's see. Then here, a into log t base a, b into log t base b, c into log t base c. And right side, k a c minus a, k b a minus b, k c a minus b. Now here put a, log t base a to the power a, log t base b to the power b, log t base c to the power c. Here this power, this one you can write as a power. Then AC cancel. Here b minus c, no? B minus c. Now AB cancel, b minus c. C minus a minus b. Okay. Now AB cancel, BC cancel, AC cancel, 0. Then log t base, log sum in product, a to the power a, b to the power b, c to the power c, 0. So if you get 0, then you say a to the power a, b to the power b, c to the power c equals 1. Equal 1. That's how we do. In logarithms, if you have value here, you can put as a power. Then for addition, you can write as a product. Okay, that is logarithm rules. That is question number 6. Okay, take time. Okay, then question number 7. Find coordinates of point I and E which divide the line joining 2 points P1, -1, 2 and P2, 4, 3 in the ratio 2 to 3, internally and externally respectively. Now here, internal external division theorem, take x1, y1, here take x2, y2. Then you say midpoint x1 plus x2 divide by 2, x2, then y1 plus y2 divide by 2, here midpoint. Okay. Then internal division theorem, here x1, y1, here x2, y2, general ratio theorem. Take point R1 here, the ratio m is to n internal. Here this is midpoint. Here internal division. Then R1 you write m multiply with x2, mx2 plus n multiply with x1, nx1 over m plus n. Here we multiply m with non-related x coordinate, mx2 plus nx1, non-related. Then y coordinate my2 minus ny1 plus ny1 over m plus n. This is it. Again check m multiply with non-related x, x2 plus nx1 over m plus n. Similarly my2 plus ny1 over m plus n. That is internal division. So if we have external division, here x1, y1, here x2, y2, here r, here the ratio m, n, external division. External division. Then you follow same pattern. You follow same pattern. Okay, same pattern. Then mx2, here m multiply by r, mx2 minus nx1 over m minus n. Then my2 minus ny1 over m minus n. Here external division, okay. Check it again. For internal division, here sum. For external division, here minus. Then m multiply by here non-related point, mx2, n multiply non-related one, nx1 over m minus n. Then similarly my2, ny1 over m minus n. External division and internal division. Then here two coordinates given. Here P1 minus 1 comma 2 and P2 4 comma minus 3. First internal division 2 to 3. First ratio, first coordinate. Then here 2 to 3. Here this is I. Internal division I. 2 to 3. Then 2 times 4 I coordinate. 2 times 4 plus 3 times minus 1. Ratio sum 2 plus 3. Y coordinate 2 times minus 3, 3 times 2. 3 times 2, 2 plus 3. Then simplify. 8, 3, 5, 0, 5, 1, minus 6, 0. Then similarly external division, here P1 minus 1 comma 2, here P2 4 comma minus 3, then here external division 2 to 3. Check the value here, 2, here 3, no? Therefore, from here 3, then E will be here. Here 3, now here 2. First coordinate 2, second coordinate 3. Huh? Then external division E, 3 times minus 1, minus 2 times 4, 3 minus 2. Then 3 times 2, minus 2 times minus 3. 3 minus 2. Here minus 3, 8, 11. Then here 6, 12. Minus 11, 12. Minus 11, 12. Okay, complete that. Question number 8 එකේ පොඩි correction එකක් තියෙනවා බලන්න. Question number 8. diagram එක miss වෙලා තියෙනවා. AB equal half, correct this one. Question number 8. Here the diagram O A B C D. Here shade this part. Here 30, here 0.5. Okay, do it. Question number 8. Point 5 මෙතන 0.5. Okay, try that question and go soon. Go forward. Okay. Now question number 8. Here 30 degree mean pi divided by 6. Area of a sector half r square theta, no? Angle theta, radius r, arc length s equal r theta. Then if the area of the shaded region ABCD, here this area, take this radius r, then ABCD area half r square theta, r plus 0.5 mean half, no? Theta mean pi divided by 6 minus, here this sector area, half r square theta, pi over 6. Sector area half r square theta. First get full area, then next area is this. Now that is twice of the area of circle of radius OA. Here sector area half r square pi divided by 6 twice. Okay. Then here first find the area of this sector OA D sector area half r square theta. Twice of that equal to ABCD area, shaded area. Then to find ABCD area, here half r square theta, here half r square theta. First case radius r plus half, and here this case radius r. Now simplify. Half pi over 6. Half pi over 6 cancel. Then here r squared plus 2 into r into half plus 1/4 minus r square equal to r squared. Then 2r square minus r minus 1/4 0. Now cross multiply. 8r square minus 4r minus 1 0. Then factorize. R 1 1 factors net half r square theta, half r square theta on the factors paid in again. There are factors. R equal minus b plus or minus b square minus 4ac root divided by 2a. Then here 4 square cancel 1 plus or minus, here 1 plus 2 root divide by 4. 1 plus or minus root 3 divided by 4. R greater than 0, therefore possible R value 1 plus root 3 divided by 4. 1 plus root 3 divided by 4. මෙතන පොඩි මට වැරදුණු තරක් තියෙනවා. මෙතන මේ circle එකේ area එකට equal නේ. If the area of the shaded region is twice of the area of the circle of radius OA. මම මේ sector area අන් ලිව්වේ pi r squared. මෙන්න මෙහෙම එන්නේ. ABCD area, circle area, twice of the circle area. radius 2 OA මේක කියන්නේ. Then ABCD half into r plus half theta pi divided by 6 minus half into r square pi divided by 6 equal 2 into pi r squared. මෙන්න මේකයි කියන්නේ. Then pi cancel. Then 1 over 2 r plus 1 over 2 square minus r square 12. Here another 5 or 6 there, 12. 2r squared. Then multiply by 12. R square r 1/4 minus r squared 24r squared. Make it set වෙන්නේ. හරි. Then multiply by 4 again. 4r plus 1 96. මේක දාවේ. අනේ මේකේ ෆැක්ටර්ස් තියෙනවද? 12 0 ne. Okay, then r equal 1 over 12 minus or r equal 1 over 8. Here contradiction, r positive no. Then r value 1 over 8. R mean OA. OA 1 over 8 meters. Pi length of OA 1 over 8 meters. Huh? Then question number 9. Question number 9, trigonometry part, 1 minus sine to the power 6a minus cos to the power 6a. Here sine to the power 6a plus cos to the power 6a. Here sine square a cube, cos square a cube. Then cube sum. Sine squared a plus cos square a. Here sine square a to the power 2 minus sine squared a cos square a cos square a to the power 2. Now sine square cos square 1 minus, here for these two write sine squared a plus cos square a to the power 2 minus 2 sine squared a cos square a. With this one, write 3. Then here 1. Then 1 minus 1 plus 3 sine squared a cos squared a. Then cancel 1. Then put 3/4 2 sine a cos a square. Then 3/4 sine square 2a. Here this is sine 2a, sine square 2a. That is question number 9. Then question number 10. Here tan alpha over 2 given 1/3. Tan beta over 2 given 1 over 2. Then you need to find sine alpha plus beta. Sine alpha plus beta equals sine alpha cos beta plus cos alpha sine beta. Then by the side find sine alpha. Sine alpha in terms of tan 2 tan alpha over 2 1 minus tan squared alpha over 2. Then tan alpha 1/3 square, simplify and get this value. And here 6, 8, 4, 3/4. Sine alpha 3/4, 3, 4, cos alpha 16, 9 √7. Then instead of sine, put 3/4. මෙතන sin alpha plus වෙන්නේ නේ plus then 10 3/5 here 4 then sin alpha 3/5 cos alpha 4/5 then sin beta tan beta given half no then sin beta 2 tan beta over 2 1 plus tan square beta over 2 then 2 half 1 plus 1 over 2 square simplify here 4 divided by 5 sin beta 4 divided by 5 4/5/3 then here sin beta 4 divided by 5 cos beta 3 divided by 5 then 25 divided by 25 1 sin alpha plus beta 1 complete. Okay, that question number 10. Usually tan 2 alpha 2 tan alpha divided by 1 minus tan square alpha. Here double angle relation. Similarly, we have sin 2 alpha in terms of tan 2 tan alpha divided by 1 plus tan square. And similarly, we have cos 2 alpha 1 minus tan squared alpha divided by 1 plus tan squared alpha. Okay, these are double angle relations in terms of tan. Very important. Nah? So if you have 4 alpha here, here this angle will be 2 alpha 2 alpha. Likewise, if you have alpha here, this angle will be alpha over 2 alpha over 2. Okay, that is double angle special relations. These are very rare cases. Very rare cases. You need to remember that. So if you consider right side, and when you simplify that, then definitely you can get left hand side. Okay, continue. Okay. හරි දැන් විනාඩියක් බලන්න. කෝඩිනේට් ජියොමෙට්‍රි ටර්ම් ටෙස්ට් එකට එනවනේ. මම ඒක පොඩ්ඩක් මතක් කරන්න. සමහර කට්ටියට කෝඩිනේට් ජියොමෙට්‍රි කරගත්ත කට්ටිය ඉන්නවා. ඒ කට්ටිය ඒක නැතුව පේපර් එක ඉස්සරහට යන්න. කෝඩිනේට් ජියොමෙට්‍රි ප්‍රශ්න තියෙන කට්ටිය මාත් එක්ක පොඩ්ඩක් සෙට් කරගන්න. මේ පොඩි සිම්පල් පාර්ට් එකක් තියෙන්නේ. හරිද? අනිත් කට්ටිය පේපර් එකත් එක්ක ඉස්සරහට යන්න. Okay. Now see coordinate geometry simple part. Coordinate geometry very simple part. Here this is we call Cartesian plane. Here y-axis, x-axis. We call Cartesian plane. Then here this point you say P x comma y, x comma y. Then y coordinate we say ordinate. X we say abscissa. Abscissa. Y coordinate we call ordinate, x coordinate we call abscissa. This we call coordinate geometry. Then here this is origin. So here with the x-axis angle, anticlockwise measured angle we call slope. And the tan value of that, tan theta we say gradient of OP. Here we denote by MOP, that is gradient. Okay. Then here R, OP length of this line segment, R we say x square plus y square root. Here this length, here length y, here x, by the Pythagorean theorem OR, x square plus y square root, OP. Here one theorem. Distance from the origin. Distance from the origin. Here gradient MOP we write, tan value y divided by x. Gradient of OP. You can directly write. Then gradient means y coordinate of x coordinate and the length of the line segment. Here line segment length we say x square plus y square root. And here with this one we say first quadrant, here second quadrant, third quadrant and fourth quadrant, like trigonometry. Trigonometry also some geometry now. Then here quadrants. Then first quadrant all xi positive, second quadrant only y positive, and third quadrant both xy negative, and fourth quadrant only x positive, y negative. Y negative. Then thereafter second thing, here x axis, y axis, you take 2 points P, Q. Then take this coordinate x1, y1, here x2, y2. Then the relation between 2 points. I am going to consider the relation between 2 points. Then here first one, distance formula PQ length. Here x2, here x1. Here the distance now x1 minus x2 minus x1 modulus. And here coordinate y1, here coordinate y2. Then here this length we say y2 minus y1 modulus. Modulus means we get only absolute value, only positive value. Okay. Then PQ length you can write here by the Pythagorean theorem, here x1 minus x2 minus x1 square plus here y2 minus y1 square root. Here distance between 2 points. Distance between 2 points, always we write x difference square plus y difference square root. Here we call distance between 2 points. Then here slope of PQ. Slope of PQ. Then by this you can get gradient of PQ, MPQ. We say tan theta. MPQ we write y difference of x difference. Here y difference of x difference. y2 minus y1 over x2 minus x1. Then or y1 minus y2 over x1 minus x2. Here gradient of PQ. Okay. So if you have two coordinates, then you can easily write gradient y difference over x difference. That's it. Then those are we call gradient. No? So when gradient zero case, we say parallel to x-axis. Gradient infinity case, we say parallel to y-axis. Then positive gradient, here theta acute angle, theta 0 to pi over 2. Then negative gradient, theta acute angle, obtuse angle. Here x-axis, y-axis, here obtuse angle. මේ always වලදී කරන part එකම තමයි coordinate geometry ගන්න. තව පොඩ්ඩක් extra part එකක් තියෙන එච්චරයි. Then here theta in between pi over 2 to pi. Here gradient relations, gradients. Then gradient 0 parallel to x-axis, gradient infinity parallel to y-axis. Here gradient positive acute angle with x-axis, m negative obtuse angle with x-axis. Okay, these are gradients. Then there's special thing again. When two lines are parallel, gradients are same. Here take gradient m1, here take gradient m2. When they are parallel, gradients are same. Then when two lines are perpendicular, take this gradient m1, take this gradient m2. Then when they are perpendicular, we say gradient product minus 1. When two lines are parallel, gradient same. When two lines are perpendicular, gradient product minus 1. Okay, gradient product minus 1. Then, but here they are special case, x-axis, y-axis, gradient 0, gradient infinity. 0 times infinity undefined. Na? Critical case, that is critical case. But all the other cases, gradient product minus 1. හරිද මේ දෙක විතරක් ගත්තොත් 0 infinity 0 times infinity we call undefined relation. But all the other cases gradient product minus 1. මෙහෙම xi එන්නේ නැතුව මෙහෙම angle ලා 90 උනා නම් here gradient m1 gradient m2 m1 times m2 minus 1 m1 times m2 minus 1. Okay, now here when lines are parallel, then gradients are same. Here when lines are perpendicular, then gradients product is minus 1. Okay, gradient product is minus 1. Then there's another thing. Here PQ point now. So at midpoint we say M midpoint. x coordinate sum divided by 2, y coordinate sum divided by 2. Then x1 plus x2 divided by 2, y1 plus y2 divided by 2. Here this is we call midpoint. Midpoint. Then if you need to find midpoint, then x coordinate sum divided by 2, y coordinate sum divided by 2, you need to consider. That's it. So then finally, section formula. First one, internal division. Check this pattern. x1, y1. Here x2, y2. Here midpoint mean 1 to 1 ratio. 1 is to 1 internal division point. But for any other ratios, you take here P, take here Q, take here R. PR to RQ, M is to M. Internal division. PR is to RQ, M is to N. Internal division. So if you need to find R coordinate, you do this say. M multiply with non-related coordinate, okay? N multiply with non-related coordinate. Here x coordinate related with x coordinate related with x coordinate, y coordinate related with y coordinate. mx2, check it, mx2, nx1, add them. Here mx2 plus nx1 over m plus n. mx2 plus nx1 over m plus n. Similarly, my2 plus ny1 over m plus n. Here internal division. Then external division, take P point x1, y1. Here Q point x2, y2. Take this R point, R dash point. Here ratio m into n external division. M into n external division. Then PR dash QR dash m is to n. M is to n. Then R dash. Similar pattern, na? Here m related with these 2 points, no? Then m multiply with non-related one. mx2, here n multiply with non-related, nx1. For internal division put sum, for external division put minus, that's it. Then mx2 minus nx1 over m minus n. Similarly, my2 minus ny1 m minus n. Here external division. External division. Here m to n internal division, here m to n external division. Those are things related with coordinate geometry. And there's another thing with collinearity, collinear condition. Collinear condition. Here when you consider A, B, C, if AB, gradient of MAB not equal MBC, when gradients are different, then ABC are not collinear. If MAB equal MBC, then here AB gradient and BC gradient both are same. That means they are on same line. No? Then A, B, C are collinear. Collinear. This is we call coordinate geometry. That's it. Coordinate geometry. Make a direct apply කරන්න theory. Origin එකේ ඉඳන් distance එක ගන්න x square plus y square root. ඔරිජින් එකකින් දාලා පොයින්ට් එකට ගහන ලයින් එකේ ග්‍රේඩියන්ට් එක ඕන tan theta value y divided by x නේ. y divided by x. Slope we call angle. Angle tan inverse y divided by x. Slope. Distance between 2 points, x difference square plus y difference square root. Gradient of PQ, y difference of x difference. Midpoint of PQ, x coordinate sum divided by 2, y coordinate sum divided by 2. Midpoint, distance formula. Gradient 0 parallel to x axis. Gradient infinity parallel to y axis. Acute angle, gradient positive. Obtuse angle, gradient negative. Gradient negative. Then when two lines are parallel, gradient same. When two lines are perpendicular, gradient product -1. PQ coordinates given internal division m to n. Here PQ coordinates given external division m to n. M to n external division. Okay. Then for that case, m multiply with non-related one. Here mx2 plus nx1 over m plus n internal division. For external division, mx2 minus nx1 over m minus n. Internal division and external division. ඔයාලට ස්පෙෂල් මතක තියාගන්න තියෙන වෙන්නේ මෙයා. ඕනනම් gradient product එක -1 කියන එකයි වෙන්නේ මේ internal division relations ටිකයි විතර. අනිත් ඔක්කොම ඕලස් වලදී කියනවනේ. හැබැයි මේ නම කියන්නේ නැතුව ඇති ordinate abscissa. Y coordinate we usually we say ordinate, x coordinate we say abscissa. Abscissa. ඒතර ඔයාලට අනිත් ඒවා නම් normal කතාව තමයි තියෙන්නේ. මේක vectors වලින් අපි discuss කරලා තියෙනවා. මේක just coordinate මේක Pythagorean theorem වලින් මේ length එක discuss කරනවා. ඒක මෙතනක් තියෙන ඒ කතාවම තමයි. හරිද? මේ gradient ගැන ඔයාලට ඔලස් වලදී කතා කරනවා. එතන මෙතනත් මෙන්න මෙයා parallel කියන එක gradient equal. Then only perpendicular thing you need to remember and internal external division need to remember. That's it. That's all about coordinate geometry. හරිද? මේක චුට්ටක් අර ඒක දැනට පොඩ්ඩක් මගහරන කට්ටිය මෙතෙන්ට එන්න. මම straight line circus කරනකොටත් මේ ටික හවව fully මතක් කරලා එන්නම්. දැනට මගහරන කට්ටිය පොඩි note එකක් දාගන්න එක මගහරනන්න. හරි ඒ ටික අපි ලියාගෙන පොඩි ඉන්ටර්වල් එකක් කරගමු. පොඩි රෙස්ට් එකක් ගන්න කියලා.